Right, so in 3.1, we talked about exponential functions. The inverse, the opposite of exponential functions are log functions. So in 3.2, we're going to be dealing with log functions. In part 1, we're just talking about properties of log functions. In part 2 of 3.2, we're going to be graphing them. So we're not graphing until Monday, but right now we're just talking about properties of logs. So our log function, if we have this here, we read it as log base A of x. So the little number on the bottom is the base. Now, it is possible to take something into log form and put it into exponential form, and take something in exponential form and put it into log form. So we can go back and forth between the two. So here's an example of log form versus exponential form. We always start with the base. The other two numbers switch position. So here the x is attached to the b, but when we put it in exponential form, it's then going to be the y that's attached to the b, and they switch. So there's an example here. We start with our base of 2, then the 8 and the 3 just switch position. So it'll be log base 2 of 8 equals 3. So let's do example 1. We're going to write each equation in the equivalent exponential form. So it starts with log form. I'm going to start with my base. What's my base for A? 2. What's the new exponent going to be? 4, and then it equals what? X. Let's do the same thing for the B. What's our base? 3. What's the new exponent? X, and it equals 9. Awesome. In example 2, we're going to take things in exponential form and put them into log. So I'm going to start with my base. So log base B. So our base is whatever the base is that has the exponent. So log base B. The other two numbers switch positions. So 16 would come next, and then it equals 4. So for B, what's our base? So log base 5 of what? What would come next? X, and it equals 2. In example 3, we're going to evaluate the function at the indicated value of x without a calculator. So we can plug in 64 into the x. Now our brain doesn't really compute logs, but we can compute exponents. So let's put this into exponential form. So what would my base be? 4. I'm going to call this y. So I'm just going to make f of x y. So what's our exponent going to be? Y is equal to 64. So 4 to what power gives us 64? 4 to the third power. So y would equal 3. Or we could do it like we did yesterday, where we made them have the same base. So 4 to the power of y equals 4 to the third power. When our bases are the same, they cancel. We just set the exponents equal. So you can think about it the same way. Let's do B. So I'm going to plug in 1/6 here. Let's rearrange this into exponential form. What's our base? 36. So 36 to the power of y equals 1/6. So we could make these have the same base, if you want to do it that way. What would a common base between the two be? 6. So I could make 36 be 6 to what exponent? 6 to the second power. So then times y equals, how would I make 1/6 be 6 to what power? 6 to the power of -1. Perfect. When you do this, be careful that you're not changing the value of things. You're just changing the way that it looks. So we're not changing the value. 6 to the second power is still 36. And 6 to the power of -1 is still 1/6. We're not changing the value of it, just changing the way that it looks. Once our bases are the same, we can cancel them out and then just set the exponents equal to each other. So 2y equals -1. What would we do next? Divide by 2. So y equals -1/2. So example 4 says use a calculator to evaluate the function at the indicated value of x. We're just going to plug in 2.7 into the x. So negative 3 times log base 10 of 2.7. Now in the calculator, calculators can only compute log base 10. So if we had a different base than 10, we would have to use the change of base formula, which I'm not sure if we talk about in this section or the next one, but we're okay here because it's log base 10. So in your calculator, I would compute the log first. So let's just do one step at a time. I'm going to do log of 2.7. Now, if you do it in the calculator, your calculator won't give you a base, but it automatically assumes that it's just going to be log base 10. Log base 10 is your common log. So when we do this, you should get 0.4313. It keeps going, but I'm going to leave it in the calculator for the last step. We just need to multiply it by negative 3. So you should get negative 1.2940. We look at the fourth decimal to tell us how to round to the third. Do we round up or keep it the same? Keep it the same. So that would be our answer. All right, on the next page, we have properties of logs. So log, doesn't matter what your base is, the log of 1 is always going to be 0. That's because if we rewrite this into exponential form, doesn't matter what our base is, anything to the power of 0 equals 1. So the log of 1 is always going to be 0. Now looking at 3 kind of goes with 2, but it applies for any exponent. If we have log base a of a, these cancel and we're just left with the x. Whatever our exponent is, that would be our answer. Same thing if I have a to the power of log base a. If these are the same base, they cancel and we're just left with x. And then in number 4, if we have a log equals a log with the same base, they cancel. We would just set what we're taking the log of equal to each other. So in example 5, we want to solve the equation for x. So here, we're going to use the properties that we just did. You can rewrite this into exponential form if you want. But how could I make 81 have the base of 3? Be 3 to what power? So log base 3 of 3 to the 4th power equals x. I'm not changing the value of anything. I'm just changing the way that it looks. Log base 3 of 3 will cancel, so we're just left with 4 equals x. Any questions there? What about for b? Log base 5 of 1 equals x. What do we say the log of 1 is? 0. It doesn't matter what your base is. The log of 1 is always going to be 0, so x would equal 0. You can rewrite this into exponential form. Same with the one above. We had 5 to the power of x equals 1. We know that 5 to the power of 0 would be 1. All right, example 6, we're going to use the properties to find the answers. For a, if our bases are the same, what do we do with them? They cancel, so we're just left with what? 15. Let's do b. If our bases are the same, what do we do with them? They cancel, so we're just left with 3. What about for c? Our bases are the same, so they cancel, but what is that exponent that we have up here? It's the power of 1. So what would our answer be? 1. Because if it was 9 to the power of 0, that would just be 1. But if it's 9 to the power of 1, that's 9. So what we're left with is 1. For d, these do not have the same base yet, but how could we make them have the same base? How could we make 1/3 have a base of 3? 3 to the power of negative 1. Awesome. And then when our bases are the same, we can just cancel them. What are we left with? Negative 1.